Overwatch is a game that takes place in the distant future. The goal is to kill the enemies and achieve whatever objective the game mode is asking for. Characters within the game have their own unique backstories, personalities, and more importantly for the sake of this video, abilities. These abilities can range from simple technology we use today, to advanced technologies beyond our understanding, to what seems to be straight magic. However, my goal today is to explain these abilities using physics concepts from the real world and prove or disprove the possibilities of these concepts becoming application one day. Let's start with the character Tracer. Tracer is a character who seems to magically manipulate time and distance and uses that to confuse her enemies and outsmart them. She does not manipulate time or distance for anyone but herself. This is applicable to the real world, as Einstein had proved that both time and distance are relative to only the observer, meaning everyone experiences them at different rates. This is achieved by traveling at a velocity close to the speed of light, which is represented by the variable gamma. Gamma is represented by this equation. Gamma equals the square root of 1 over 1 minus v squared over c squared. Let's say, for example's sake, that Tracer is traveling at 0.99 c. This means that her gamma value is 7.08. Tracer must somehow be able to accelerate herself instantaneously close to the speed of light in order for her to be able to manipulate the distance she experiences. This lets her seemingly dash to a spot without having traveled through the displacement between her start and end points. The length Tracer experiences is represented by the equation Lm equals Ls over gamma, meaning that as her speed gets greater, the length she experiences gets smaller. If she were to dash 5 meters, she would have experienced it as 0.7 meters, explaining how she instantaneously travels that distance. However, this doesn't explain how she manages to travel herself backwards in time. With our current understanding of the universe, this is impossible. Yet, if we graph out the value of gamma over the speed of light, we can see that there is an asymptote at c. If we were to somehow travel at a speed greater than c, then gamma should begin to move backwards from infinity back down to 1, assuming it has the same behavior beyond c. This would hypothetically allow for backwards travel in time, which is how I believe Tracer manages to travel back in time. This would also explain why she is the only person who experiences backward shift in time, as she is the only person whose speed is greater than the speed of light. As our gamma value approaches infinity, our relativistic mass, represented by mr equals gamma m, also approaches infinity. Using her previous gamma value, and assuming she has a rest mass of 45 kilograms, her relativistic mass would be 318.6 kilograms, only getting greater exponentially as her speed increases. This means that for Tracer to travel faster than the speed of light, she would require an infinite amount of energy to accelerate herself any further, due to Newton's third law, F equals ma. Tracer also has an ability where she throws out a pulse bomb, where the closest enemies are killed instantly, and those who survive are blown back a few meters. Those who aren't in close proximity aren't affected at all. This could work in the real world, using an extremely powerful electric field with a very high negative charge. This would cause a repelling force on all the electrons, in turn repelling the electrons off of those who are closest, shooting them off of their body and killing them, as matter cannot exist without electrons. The bonds within the human body would be destroyed instantly, removing all bonds that these atoms have created that keep us alive. This would also explain why those who aren't within close proximity aren't affected at all. The equation for the electric force between two charges is the force is equal to the k constant times the first charge times the second charge all over the distance between the two squared. This shows that as the distance between the two charges gets bigger, the force exponentially gets smaller, explaining why those who are far away are left unscathed and those who are close are killed instantly. In order for this to work, the charge would have to be a massive negative number to rip off the electrons in the body. Let's assume the force applied on the electron is 2,000 newtons, and there is 1 meter between the enemy and the bomb. We also know that the charge of an electron is negative 1.6 times 10 to the minus 19 coulombs, and rearranging for the second charge gives us the value of negative 1.4 times 10 to the 12 coulombs, which is a massive charge for a single source. To move on past Tracer, let's take the example of Farah. Her main gimmick is that she uses her jetpack to accelerate herself upwards and shoots rockets at her enemies from above. But let's focus on her jetpack. How much energy would it take for her to use her jetpack through one flight without recharging? We first have to assume her mass, which with her bodysuit being assumably heavy, let's say weighs 100 kilograms. Let us also assume that she travels 10 meters into the air. Her total energy at the peak of her flight is represented as gravitational potential energy, which is shown through E equals mgh. Yet any person falling 10 meters would do a decent amount of damage to their legs, yet Pharah seems to be unfazed by her landing. So how much force is being applied to her as she lands? We know that her energy at the top of her fall is the same as the energy at the end of her fall, which can be represented with energy initial is equal to energy final. Knowing her energy at the end of her fall is kinetic energy, we can set up the equation as so: mgh equals 1 over 2 mv squared. Solving for v gives us a value of 14 meters per second. Knowing this, we can plug this into our impulse equation and find out how much force would be applied on Pharah's legs as she lands. That equation states that the mass times the change in velocity is equal to the force times the change in time, and assuming that the landing takes place over a fraction of a second, say 0.1 seconds, we can rearrange for force to find that 14,000 newtons are applied on her legs upon impact, which should break her legs and might even kill her. This means that Pharah must have some way of reducing the time of the impact within her suit, which in turn reduces the force of the impact. Pharah also has an ability where she shoots out a rocket which gives a blast that pushes her and her opponents back a significant distance without doing any damage to them. I believe this to be possible through the use of a large magnetic field. This field would be created through a large amount of electric current. But how much current would be required to push her back? First, we need to assume that she is being pushed with a force of 10,000 newtons. The rocket is 1 meter away, and the length of the wire within the bomb must be 1 meter long. The magnetic field strength is equal to mu naught times the current over 2 pi r, and the force of the magnetic field is equal to the strength of the field times the current times the length of the wire times the sine value of the angle between the magnetic field and the electric current, in this case being 90 degrees. In order to do this, we need to plug equation 1 into equation 2. This will remove the b variable and give us the equation here. Using this, we can rearrange for current, giving us this equation here. Plugging in our numbers, we can find that the current required for this would be 4.1 times 10 to the power of 5 amps. The amount of energy that would require in such a small region is unreasonable and would not be achievable anytime in the near future. Sombra is a character which uses her agility to outsmart and outplay the enemy she is facing. She can confuse the enemy by using her teleporter, which takes her instantaneously from one position to another. Teleportation has been a topic of many science fiction stories in the past, yet it has always been played off as impossible. Yet it could be possible on paper. We know that Einstein states that matter and energy are rather one concept, related through E equals mc squared. Somehow this teleporter must convert Sombra's mass into a form of energy. If we assume she is the same weight as Tracer, say 45 kilograms, we can find the energy her matter contains, excluding any other kinds of energy, that being 4.05 times 10 to the 18 joules, which is an unimaginable amount of energy. The way I believe this to be possible is through the wave nature of matter, meaning that matter could somehow be interpreted as a wave, a form of transferring energy. This could be done by the teleporter sending that energy to the other end of the teleporter, where it could be reconstructed on the other end. The wavelength of the matter would be represented by the equation lambda equals Planck's constant over mv. Assuming she is at rest to a measurable amount, let's say her velocity is 10 to the power of minus 6 meters per second, we can find that her wavelength would be 1.47 times 10 to the minus 29 meters long. This means that the teleporter must be able to measure the precision of the wave down to 1.91 times 10 to the 14 times more accurate than the measurement of an electron. This would also require a battery larger than the annual energy consumption of the Earth in 2013. Also, finding a way to convert matter into energy with 100% efficiency is, to our current understanding, near impossible. Therefore, I believe this concept is not realistically possible with our current understanding of physics. However, what is possible is Sombra's ultimate ability, where she sends out an EMP, electromagnetic pulse, to disable her enemy's abilities. This is a concept that has existed and been applied since the 1960s. Our electronics run through a balance of magnetic fields and electric fields existing in equilibrium to power our electronics. What an EMP aims to do is to cripple devices in the area by sending out a pulse of an extremely powerful electric field, in turn greatly increasing the magnetic field caused. This field can be represented by epsilon equals the K constant times the charge over the distance squared. Assuming the EMP takes place over the radius of 15 meters and the charge within the field is, say, 50 coulombs, a large charge for an electric field. This will give us an electric field strength of 2.0 times 10 to the 9 newtons. This can, in real-world applications, do permanent damage to electrical grids and the systems they run, but we have only gotten a charge strong enough to give such a great force with the nuclear warheads, which are extremely unstable. In Overwatch, Sombra somehow controls this extremely unstable charge and uses it on command. Overwatch taking place in the distant future might seem like a stretch in certain areas of physics. Maybe, with enough time and scientific developments, these concepts can be applied in a real-world scenario. However, it would require advanced developments in physics, from quantum mechanics and special relativity, completely rethinking how we understand the world. Who knows? Maybe there will be new concepts applied in the future that completely disregard what I have argued. That's the beauty of science, is that it's constantly changing.
Team up for special attack.